Hello, good morning everybody, and today I wanted to demonstrate natural product chemistry for the tutorial or for home based tutorial. This is very important for you guys to understand the concept behind the chemistry of natural products. So I am Tirfu Ilma from Haramaya University, and I am a medicinal chemist actually. So I want to teach you what this interesting tutorial video for you guys. So as to these courses of can be used for what for defense mechanism as well as for ecological purposes. Yes, so once you have to stay on this tutorial video, you have to know this concepts. So when you come to the introduction part, this introduction part deals all about primary and secondary metabolites, which can be what mediated or synthesized by using what an enzyme and coenzyme as well as cofactors. So before dealing about primary and secondary metabolites, first what mean by natural product by itself. So we try to define natural product as a chemical substance produced by living organisms, and this term can be used commonly and refers to chemical substance found in nature that have a distinctive pharmacological effects. Yeah, so we say that any chemical substance that produced in living organism as a natural product. This living organism encompasses what? Organism like bacteria, fungus, plants, algae, and the different marine species as well. So any chemical that emanates from this such type of living organism is known as natural product, and this natural product is commonly have what? A pharmacological effects. So the sub-objective of this course is what? To understand the general difference between primary and secondary metabolism, to appreciate the origin of secondary metabolites, to recognize the major building blocks that are used by nature to synthesize secondary metabolites, to understand the ecological roles played by these secondary metabolites, mean that the interaction of microorganisms with their environment. Yes, so this secondary metabolite is very important for the ecological role as well. And to understand the molecular mechanism of the most important enzyme catalyzed reaction in primary and secondary metabolism associated with coenzyme, cofactors, and enzyme as well. To appreciate the similarity and the difference between the chemical reaction in a cell and the intestine. Yeah, from your pharmacology concepts, you know that we have two types of reaction or chemical reaction, the in vivo and the in vitro one. The in vivo means the inside of the cell, whereas the in vitro means that the outside of the cell, which means that maybe the test tube by itself. So once you have to stay in this video, you have to identify or you have to differentiate what this in vivo and in vitro or chemical reaction that undergoes by plants and the different microorganisms as well. We will come directly to the introduction. Any organism that exists on the Earth's crust can vary widely in their capacity to synthesize and transform chemicals. For instance, if you take plants that are very efficient at synthesizing organic compound via photosynthesis from inorganic material found in the environment like carbon dioxide and oxygen as well as sunlight, while other organisms such as animals and microorganisms rely on obtaining their raw materials in their diets, which means that by consuming the plant, you know that we human being by itself 100% rely on the plants and different microorganisms so as to survive on the Earth's crust. Yeah, so this one is the concept behind. And this plant produce a chemical compound as a part of their normal metabolism functions, and the compounds synthesized by the plant may be divided into two major groups, that is primary metabolite as well as secondary metabolites. So what mean by primary metabolite? Primary metabolism comprises the chemical process that every plant must carry out every day in order to survive and reproduce its life. So this primary metabolism is universal, and it is very critical for survival and reproduction purpose. So these photosynthesis, as you know, glycolysis, synthesis of coenzyme, Krebs cycles or citric acid cycle, synthesis of amino acid, transamination, synthesis of coenzyme, reproduction of cell or growth, synthesis of structural material, as well as duplication of our genetic material or DNA is the best example of what primary metabolism. So these primary metabolites or primary metabolism is what are compounds synthesized by the plant which are needed for growth and development. As I mentioned before, these primary metabolism or primary metabolite are what that the universal and the essential component needed for the survival of living organism needed to create what and maintain their life. For example, these carbohydrates, lipid, proteins, and the nucleic acid are what the primary metabolite. So the compounds are involved in the energy regulation of an organism and with the growth and the development of the tissue. In short, they are the building block of an organism. Therefore, you have to know that this primary metabolite is directly involved in the growth and the survival purpose, and they can be prepared always for by different plants or living organisms. That's why we say that they are a universal. They are what? The universal. So you have to identify primary metabolite like this. So what the distinction between primary and the secondary metabolites? So primary and the secondary metabolites cannot be readily distinguished on the basis of the precursor molecules, the chemical structure, or the biosynthetic origin. So how we can identify? This means that the primary and the secondary metabolite may have a similar precursors and the similar chemical structures may have, or the biosynthetic origin also may be similar. So by this criteria, we cannot identify or cannot separate this one is primary or this one is secondary. For example, both primary and secondary metabolites are found among the diterpenes C20 and triterpene C30. This one is what the terpenoid classes. So both may have this one. So by this structure or chemical composition, no one can identify this one is primary or secondary metabolite. For example, if you take carboxylic acid and abietic acid, their structure may similar, slightly similar, of course, actually. So this structure may cannot be help us to identify whether carboxylic acid or abietic acid is primary or secondary metabolite. So, but the only difference of this primary and the secondary metabolite are highly rely on the definition. For example, if you take carboxylic acid is an essential intermediate in the synthesis of what the gibberellin, which is the growth hormone found in all plant. So what we say before is that if something can be directly involved in the growth and the survival, we say that the primary metabolites. When you come to abietic acid, which is mainly found in the resin component, largely restricted to the member of what the Fabaceae and the Pinacea family, and this abietic acid may be used for what defensive mechanism. Therefore, if something cannot be involved in or directly involved in growth and the survival purpose, we say that secondary metabolites. So by their structure or precursor, we cannot identify primary and secondary metabolites. Rather than we have to highly rely on their exact definition of what the theoretical definition of the primary and the secondary metabolites. Proline and pipicolic acid, as you see, both are what nitrogen containing compound, but pyrroline is an essential amino acid, which is a primary metabolite, and pipicolic acid is what an alkaloid, which is secondary metabolite. So in absence of valid distinction based on either structure or biochemistry or biosynthetic origin, we return to the functional definition, which means that the definition of primary and the secondary metabolites. So primary product participating in nutrition and the essential metabolic process inside the plants, and the natural or secondary metabolite or product is influencing the ecological interaction between the plant and its environment. Therefore, secondary metabolites are organic compounds that are not directly involved in normal growth, development, or reproduction of the organism. Kanaafuu bifa kanaan adda baafna jechuudha. Primary kan jennuun kanneen kallattiimaan growth fi survival keessatti directly involved warroota ta'an yoo ta'u, alkallattiidhaan growth fi yookaan immoo survival as well as development irratti yookaan guddina irratti yookaan jiraachuu irratti karaa alkallattiitiin kan influence qabu yoo ta'e immoo secondary metabolite jennaan jechuudha. So you have to identify primary metabolite and the secondary metabolite by this theoretical definition rather than on their chemical precursors. So how do plants synthesize this compound? So this secondary metabolite can be produced by the plant if it is required. So how? So we have two type of synthesis mechanism. We say that the in vivo and the in vitro. Yes, this is what this unit is all about, deals about. So how do the miracle biosynthetic origin of the plant can be takes place? Despite the diversity of secondary metabolites, a few key intermediates in primary metabolism supply the precursor for most secondary metabolites. This means that many secondary metabolites can be synthesized or biosynthesized by using an intermediate in primary metabolism. So secondary metabolites are produced by the pathway derived from primary metabolites routes. Have a look this. The left one and the right one is what show that for example, primary metabolism, carbon dioxide plus water, by the principle of photosynthesis, they directly produce what? Glucose. So this glucose by glycolysis can give this intermediates, phosphoenol pyruvate and erythrophosphate phosphate. This one is the two intermediate that can obtain from glucose by glycolysis. So these two intermediate can be very important for the synthesis of shikimate. Shikimate is the precursor for the secondary metabolite like cinnamic acid, derivative aromatic compounds like lignan and the flavonoid. So for this secondary metabolite, this shikimate is what the precursor. So secondary metabolite can be obtained by using the primary metabolite as an intermediate. When you see this phosphoenol pyruvate also convert to pyruvate, so pyruvate can be interdirectly in amino acid synthesis. Amino acid is a precursor for alkaloid, which is secondary metabolite. Not only this, in Kookeef cycle, when you see acetyl coenzyme A and malonyl coenzyme A, they are very important to biosynthesize fatty acid and the polyketide as secondary metabolites. Not only this, for terpenoid also, this primary metabolite can be used as a precursor for secondary metabolite. So you have to apply this principle. The scheme outlines how metabolites from the fundamental process of photosynthesis, glycolysis, and the Kookeef cycle are tapped off from the energy generating process to provide biosynthetic intermediates. Animal, including like humans and most microorganisms, depend directly or indirectly on the plant as a source of the food. So plant cells contain far more compounds than other produced by the basic primary metabolism. Yes, so the plant cell contains far more compounds than are produced by the basic primary metabolism. So in contrast to this primary metabolic pathway, which synthesize, degrade and generally interconvert compounds commonly encountered in all organisms, there also exists an area of metabolism concerned with compounds which have a much more limited distribution in nature. So in addition to primary metabolite, plant also produce a vast and diverse assortment of organic compounds, the great majority of which do not appear to participate directly in growth and development. The secondary metabolite does not or do not appear to participate directly in growth and survival as well as development. This one is a distinct feature of secondary metabolites that differ from primary metabolites. So these substances traditionally referred to as secondary metabolite or natural products, often are differentially distributed among limited taxonomic groups within the plant kingdom. So secondary metabolism comprises the chemical processes that are unique to a given plant and are not universal. This one is also the second distinct features of primary metabolite and the secondary metabolite. When we come to primary, they are universal, but this secondary metabolite may be unique to the given plant. This means that maybe some plants have only alkaloid, but the other plant maybe have a flavonoid. So this one is the basic feature of secondary metabolites. So primary metabolites are found in only specific organism or group of organisms and are an expression of the individuality of the species. So secondary metabolites are those metabolites which are often produced in the phase of subsequent growth, have no functioning growth, although they may have survival function, that are produced by certain restricted taxonomic group of the plants. This makes secondary metabolite distinct or differ from primary metabolites. Example of secondary metabolites include fatty acid, terpenoid, anthracene, flavonoid, phenylpropanoid, alkaloid, and extra. Some of which have a good pharmacological properties, and nowadays, most of the drug can be synthesized or obtained from these secondary metabolites. So the scientist or the researcher can be now struggling for finding the drug which is what a low resistance to the microbial infection, and having what the low cost and toxicity. So this can be what managed from natural product drug discovery. So we'll see this also at the end of this courses. So this metabolism is, you know that from your biochemistry concepts, metabolism is the sum of all chemical reactions that takes place in the living and organisms, and this metabolism can be what either primary metabolism or secondary metabolism. So primary metabolism means that all chemical reactions necessary for life of the organism by itself, and secondary metabolism or metabolite are all chemical products that are produced by living organisms but not involved in primary metabolism, and not necessarily for the life of the organism itself, but useful for interaction with with each other, like chemical communication, the chemical defenses. Especially the phytoalexin chemistry is very crucial for defense mechanism. You know that pheromones, hormones, and allomones are very, very important chemicals in communication scenario. For example, if you take hormones, hormone is what a chemical product used in the transfer of information between the tissue and the organ within the body in order to coordinate their activity, whereas pheromone are a chemical products used between individuals of the same species in order to induce specific behavior or chemical communication. But allomone is a chemical product released by an organism which has a negative effect on another organism. Yes, this one is the chemical defense. Yeah. When you see these pictures, this can be what the chemical communication or aerial pheromones, and how ants can found their foods by moving from their nests by using these chemical communication mechanisms. So this diagram shows that how these chemicals, they release this chemical that show the direction where the food can be obtained. This is a morphine. You know that the opioid analgesic drug, and it is the best anti-pain drug that can be given for the high pain disease like cancerous disease under the direction of under the supervision of the physician. And this morphine can be obtained from poppy or Papaver somniferum and the Papaver sinigera plant, and it is mainly used for difficult pain as anti-pain drugs. So morphine is found only in poppy or Papaver somniferum and the Papaver sinigera plants. And this pyrathrine 1, the pyrathrine 2 also the secondary metabolite that can be obtained from Chrysanthemum cinereifolium. So are exclusively synthesized by the genera of Chrysanthemum and the Pyratarum of the Compositae familia. This one is called the secondary metabolites distinct or specific for Compositae family. Yes, this also show that how the animal or the different microorganism can be communicate or sexual pheromones, which is very, very important in the pollination also. And so this also is the secondary metabolite that that's used for the plant for their sexual intercourse scenario. So evolution give a different organism different chemical tool to communicate with individual of the same species or to defend themselves against the predators. Have a look at the question. As we share the same kind of primary metabolism, doesn't those chemical tools have the effect on the human body? Yeah, definitely the answer is yes, because sometimes those chemical tools can be used for human beings, especially as a medicinal drug. For example, different pharmaceutical industry, different psychoactive or stimulants, flavoring industry, spice industry, perfume industry, dyes industry, natural insecticide, and the functional food can be used as secondary metabolites. So they have direct effect on survival of human beings. Also, these secondary metabolites. When you come here, this secondary metabolite or natural product have different pharmacologically active ingredient that used for the drug in clinical trial or the drug in preclinical trial or the drug which is kind of in the commercial market. Have a look at this digitalis purpurea, a natural product having a particular activity on the human body which is benefit for the for the treatment of particular disease. For example, for heart failure, this digitalis or digitoxin is a tablet that can be used for strongly stimulate the contraction of the heart and used for the treatment of deficiency or heart deficiency. So they are very important in medicinal value. Have a look. The aspirin that we are using nowadays on the market can also be for the first time produced from this willow tree by Felix Hoffman, a natural product which are slightly modified in order to improve their activity or decreasing their side effect. Yeah, before 400 BC, the use of bark under the leaf of willow tree can relieve a pain and a fever. However, due to their gastroirritant effects of this active ingredient from willow tree, for a long time this aspirin or the salicin, which is found in aspirin as active ingredient, can be does not used for medicine for the long period of time. But after the prodrug technique, this aspirin or this salicin found in the salicylic acid can be used for the production of aspirin, which is nowadays also can be given as the anti-pain drug and the fever drugs. So this one is now we have also synthesized this aspirin in laboratory by simply using acetic anhydride and the salicylic acid in the presence of sulfuric acid as a catalyst. Through SN2 reaction, we have to synthesize aspirin in laboratory. So yeah, you know that the drug discovery scenario can be directly depend on natural product drug discovery, synthetic and the semi-synthetic. So this aspirin can be directly obtained from the natural product as well as from synthesis perspective. When you come to synthesis and the semi-synthesis, the Taxol story, this Taxol also the first anti-cancer drug that can be obtained from the plants Taxus brevifolia and the Taxus baccata, and this drug can also be obtained from the natural product actually. So 960, the Berkeley isolated Taxol from the bark of this Pacific yew tree Taxus brevifolia present is very small quantity. Yes, one of the limitation of this natural product drug discovery is the amount or the dose we obtained from that, and the similar problem can be faced on this Taxol also. So 1000 years old tree to isolate 300 milligram. The single dose need to be prepared. That's mean. So this one is very dangerous to get a large amount of dose. So the total synthesis starting from simple commercially available molecule more than these steps, less than 1% total Taxol. So semi-synthetic starting from complex natural product that is using an intermediate known as 10-decacetyl basatin discovered from the needles of European yew tree or Taxus baccata. By using 3 steps, you have to get 50% of the total yield. So this semi-synthetic or semi-synthesis scenario is very important to increase or to boost the amount of yield in short. When it comes to synthetic products that are structure partially similar to the non-natural product, quinine also very important anti-malarial drug which can be used for treatment of fever, pain, and the malaria. Also isolated in 1820 by Cavento and later or friends from the bark of the cinchona tree brought back from the South America by Jesuit missionaries. So this quinine still now can be used for anti-malarial drug because they have a secondary metabolite alkaloid. So this one is very important scenario of natural drug discovery. So Datura which is the used for ease motion sickness, and the cinchona papsine or quinine which is anti-malarial, Cataratas rosas or Vimplast in the Vincristi which is can be anti-cancer drug, and ephedra which is used for reduced nasal clinician or asthmatic drug, and the Papaver somniferum which is a source of morphine, codeine can be used for pain, as well as Taxus brevifolia for Taxol, and which is used for anti-cancer. So this all figure of this all plant can be a source of medicine and which is a source of secondary metabolite. So why do plants produce this secondary metabolite? In short, plants produce secondary metabolite for the survival as well as for ecological purpose. So ecological means for the interaction with their environment. Yeah, for this purpose, this plant can produce secondary metabolite. function or the importance of secondary metabolite in a plant is ecological. It is for the interaction between the plant and their environment. That means, so plant can't run away. You know that plant cannot be run away, cannot defend, cannot speak. Yes. So to avoid their enemy, they can produce what? These secondary metabolites. Have a look how God can be what a miracle for the His creator, because God himself can give the plant this secondary metabolite as a weapon. Yes, as a weapon. So plant can run away, and so they develop a weapon to protect themselves. This weapon may be as simple as spines, but are often complex chemical components. So the plant synthesize secondary metabolite to defend themselves against herbivores, microbes, viruses, and different pathogens usually. So plant produce repellent to protect themselves from predators and antimicrobial to fight off parasites. Fungi attack plants by producing phytoalexin together with enzyme that digest plant tissue. So in response to this attack, the plant produces phytoalexin, which acts as a natural antifungal agent. Do you know barley, which is garbu in Afan Oromo or gabs in Amharic, mainly found in the highest altitude of the Ethiopian parts, especially in Daga. And this plant can be mainly affected by what? Fungal attack. So this plant or this barley can produce what? Resveratrol, secondary metabolite, which can be used to defend this fungal infection. So now we human beings take that resveratrol still for different purposes. That's why by different vitamin can also be found in barley, and this barley is very important for health. And this secondary metabolite resveratrol nowadays can be what? On the trial of what? So this phytoalexin is a natural product produced by the plant in response to stress. Some examples are chitin, which is produced by the potato, Solanum tuberosum, and the physolin, which is produced by the bean, Phaseolus vulgaris, or rechitin, or a phasolin. This one got a phytoalexin that is very important, crucial for humans. So to facilitate the reproductive process, yes, different coloring agent in plant can also be what? Secondary metabolite to protect themselves from excessive UV light or UV radiation. Yeah, exposure to UV radiation induces the biosynthesis of UV absorbing component. This is also the role of plant. For example, different medicine like ephedrine, anti-asthma, and ricinus communis, which is from castor and mainly used for constipation, can also be what? Secondary metabolite from plant. Perfume industry can use this secondary metabolite for as a raw material for geraniol. Geraniol, if you took from geranium oil, can also be what? Used for perfume industry, spice industry. You generally know that, and the cinnamaldehyde also from cinnamon species can be used for spices. So spice industry, medical industry, perfume industry can use this secondary metabolite as materials. Narcotic industry, hallucinogen like morphine, opium tree or Papaver somnifera, and tetrahydrocannabinol or hashish, marijuana from cannabis sativa can be used for hallucination. Yes, you know that the chat, especially which is mainly found in hierarchy, can also be what? A hallucinogen effect because it have an alkaloid cut inside. Cathinone in chat also can be used as a narcotic in the hallucination. So the most important building block employed in the biosynthesis of secondary metabolites are directly from the intermediate acetyl-CoA or acetyl-CoA and the shikimic acid as well as mevalonic acid. These are the most building blocks employed in the biosynthesis of secondary metabolite. So many secondary metabolites can be derived from acetyl coenzyme A, shikimic acid, and mevalonic acid. So when we start this chapter, we say that we have two types of reaction, chemical reaction, especially in the cell, in the flask, in the vitro, in vivo, and the in vitro domain. So just like the synthesis of organic compound in the laboratory, the synthesis of organic compound in the cell require reaction that can be used to form what? Carbon-carbon as well as carbon heteroatom bonds to the target compound. However, because of the biosynthesis of secondary metabolite occurring in living cell, there are several restrictive constraints on the reaction which may be used to convert one metabolite into the other. But two restrictive constraints are there. So the most restrictive constraint is the consequences of two unavoidable facts about living cell. One, the living cell is mainly water, so many of the organic reaction must be carried out in an aqueous solution. The second one is the pH of the cell deviates even by the half of the unit in a cell, that is pH is equal to 7.5, which means that the pH of our blood. So our blood can be what the buffering agent like carbonate and bicarbonate, so as to regulate the pH to 7.35 to that of 7.45, which means approximately 7.5. The cells above this, the cell may be what first the cell base dies due to alkalosis. So consequently, whenever the cell synthesizes an organic compound, it must do so in an aqueous environment using the reaction that do not require strong acids or bases. So one way in which the cell avoids some of the difficulty imposed by this constraint is to use enzyme as a catalyst for many reaction. So the enzyme function by bringing the reactant together in the suitable orientation, and they also function by producing a microenvironment which means conducive to the reaction, so facilitating the environment for the reaction that it is. So the role of enzyme in natural product chemistry can be, so when you see this role of enzyme in natural product chemistry, the biosynthetic reaction are reversible and are catalyzed by enzymes. This enzyme are a protein, you know that, which is a biological catalyst that we mean. So enzyme catalyze the same types of reaction that are utilized in any organic chemistry laboratory, like oxidation, reduction, alkylation, hydrolysis, hydroxylation, elimination, and the different reaction can be takes place in the laboratory. You know that these reaction, same reaction can be takes place inside the plant. Yeah, this enzyme can be known by what reducing the energy gap. Yes, the energy gap can be what reduced by this enzyme, because the activation energy that it means, the activation energy can be always what decreased by this enzyme. So the role of enzyme can be enhancing or increasing the rate of reaction by increasing what activation energy is doing. So the hallmarks of some enzyme catalysts are speed, selectivity, and specificity. This one is a basic feature of an enzyme. Enzyme can speed up the rate of reaction. Enzyme can be selective. Enzyme can be what? Specific. So selectivity means the ability of an enzyme to select a certain substance or functional group out of many. Specificity means that the property of the reaction catalyzed by the enzyme being the production of a single regio and the stereoisomer of the product. Yeah, this one is specificity of the enzyme. So the catalytic activity of many enzymes depend on the presence of small non-protein molecules that is known as cofactors and the coenzyme. Cofactors are classified as inorganic substances such as magnesium plus, zinc 2 plus, iron 2 plus, iron plus 3 in the different minerals. So small organic molecule known as coenzyme. Coenzyme are organic, whereas cofactor is what? Inorganic. So the difference between coenzyme and cofactor is what? Cofactor is an inorganic compound, whereas coenzyme are organic molecules that are required by certain enzyme to carry out catalysis. These coenzymes include like ATP, CoH, NAD, SAM, yes, PLP, NAD, biotin, and the DMAPP, dimethyl allyl pyrophosphate, S-adenine, methionine, SAM, pyridoxal phosphate is PLP, adenosine triphosphate is ATP, like this. These are a coenzyme or specific coenzymes that are very important for the biosynthetic route of secondary metabolites. ATP, you know that adenosine triphosphate. These adenosine triphosphate can be mainly used for what? Activate the chemical reaction and make thermodynamically unfavorable reaction to thermodynamically favorable reaction. So it is facilitating the that means that it creates the conducive environment for the reaction. Simply, this ATP can be used for creating a conducive environment for the reaction. How? By simply converting thermodynamically unfavorable reaction to thermodynamically favorable reaction. Thermodynamically favorable reaction. In vitro, as I mentioned before, it is simply in the test tube, whereas in vivo means inside of the cell. Inside of the cell. So the carbonyl that you look in the carbon of an alcohol is electrophile because of OH, and however the OH ion is a poor living group, so we have to add one hydrogen so as to make it water, which is a good living group. So the hydroxyl group can be converted to the tosylate, which act as a very good living group, a very good living group. Tosylate is a good living group. So energetically unfavorable reaction is biosynthetically driven by linking it to an energetically favorable reaction such as hydrolysis of what? ATP. Coenzyme A, acylation and the formation of carbon-carbon bond, formation to alpha carbonyl carbon. So coenzyme A is one of the most important acyl transfer and alpha carbon activation reagent in living organism. This is the role of coenzyme A. It is very important coenzyme actually in different scenario, and different reaction like methylation also. Reaction in biological synthesis takes place. This methylation can be always undergoes by using SAM as a coenzyme. SAM can be used as a source of methyl group. Yes, SAM is what? S-arnesyl methionine. Yerunda SAM argitan tanan kallattiman source of methyl group yakate bekun isinirra eegama jechuudha. Yerunda SAM source of methyl group jechuudha. So SAM acts as a versatile oxygen, carbon, nitrogen as S-methylated agent in vivo or inside the cell. So oxygen then alkylation also mediated by using SAM. Still SAM, the role of SAM can be acting water, simply adding an hydrogen and methyl. This is CH3. So this one is the structure of SAM. It's adenosine methionine. It means SAM is adenosine methionine. So always SAM can be what? A source of methyl. ስለዚህ ሳም ምንድን ነው የሚያደርገው? ስፔሻሊ ሰከንደሪ ሞዲፊኬሽን ላይ ሚቲል ነው የሚሰጠው ማለት ነው። የሚቲል ዶነር ነው ማለት ነው። CH3 ዶነር ነው ማለት ነው። ስለዚህ ሳምን በየትኛውም አጋጣሚ ብታዩት ሚቲል አድርጓል ማለት ነው ሰከንደሪ ሞዲፊኬሽኑ ላይ ወይም ደግሞ ሰከንደሪ ፕሮዳክቱ ላይ ማለት ነው፣ ናቹራል ፕሮዳክቱ ላይ። ሌላው ዳይሚታይል አሊሌሽን ነው። This dimethyl allyl group is very common substituent in secondary metabolite, and this dimethyl allyl pyrophosphate is always the source of what? Prenyl group now. This one is a source of prenyl. Yerohunda dimethyl allyl pyrophosphate argitan tanan indiku yerohunda prenyl group prenyl group jechuun carbonation dabalatan kan kennu danda'u jechuudha. 5 carbon ያላት ፕሪኒልን ግሩፕ የሚሰጥልን ሁሉ ጊዜ ዳይሜታይል አልያል ፓይሮፎስፌት ነው። ስለዚህ ይሄ ሰከንደሪ ሞዲፊኬሽን ነው ማለት ነው። ሰከንደሪ ሞዲፊኬሽን ማዲት የምናደርግበት አንዱ ኮኤንዛይም ማን ነው? ዳይሜታይል አልያል ፓይሮፎስፌት ነው ማለት ነው። ስለዚህ በዚህ አግባብ ነው ልትረዱ የሚያስፈልገው ማለት ነው። Yeah, so this one is prenylation. As I mentioned before, prenylation can be takes place by using what? Dimethyl allyl pyrophosphate. Dimethyl allyl pyrophosphate prenyl group can be attached like this. So carboxylation, decarboxylation can also be takes place by this secondary metabolite. So here biotin in the presence of bicarbonate, ATP in the magnesium plus enable nucleophile carboxylation in vivo or inside the cell. So this biotin is a cofactor which can be act as the source of carbon dioxide using carboxylation reaction. The reverse is decarboxylation, which can be mainly undergo by PLP can have what? Decarboxylation role also. So oxidation, the reduction reaction can also be takes place by using different reducing agent like sodium borohydride, lithium monohydride, magnesium permanganate, potassium permanganate. This all can be used as a reducing agent in cellular and in vitro cell, but inside the cell we have different reducing agents like DAPP and DMPP can be used as a reducing agent. And hydroxylation and epoxidation also takes place. Yes, this epoxidation and the alkene epoxidation can be takes place to produce what? Epoxide or oxide compound, and here different catalysts can be used for this reaction. So the enzyme monooxygenase catalyst can be the insertion of an oxygen atom across the carbon-carbon double bond to form an epoxide. So here we use what? NADPH can be used inside the cell or in vivo as a source of oxygen under the carbon double bond. The other one is reductive amination in nature, and one of the best method of amine synthesis in the laboratory is reductive amination, in which an imine formed from the carbonyl compound and an amine is reduced to the saturated saturated amine. Here also we have to use different reducing agents like sodium cyano-borohydride like this, and the sodium borohydride also can be used. This reaction of course produces what? Racemic amines. Racemic amine means that the mixture of 15R and 15S, this one is known as racemic amine. This means that the reaction is not regiocentric or nacho-specific reaction. For this transformation, the nature uses a substituted pyridine called pyridoxal phosphate PLP, which is a reversible reaction yields stereospecific products. So these pyridoxal phosphate PLP have different role among the transamination, decarboxylation can also be the role of pyridoxal phosphate transamination, decarboxylation, and alpha beta cell transfer also the role of this PLP. When reductive amination or reverse is required, the pyridoxal is transferred from the lysine imine to the carbonyl group of the substrate to form a new imine of the same sort. So the most important substrate for PLP are an amino acid and their equivalent alpha keto acid. So aminotransferase takes place by what? This is PLP. So an alpha amino acid can be converted to alpha keto acid by using this PLP enzyme. The reaction is actually a reversible reaction. So transamination that can takes place by PLP using that. So several different kinds of amino acid transformation are catalyzed by PLP requiring enzyme, and the most common transformation are decarboxylation, transamination, racemization or the interconversion of L and the D amino acid, and alpha beta bond cleavage as well as alpha beta elimination. These all can be what the role of what? Pyridoxal phosphate or PLP. So decarboxylation is one scenario in which the acid functional group can be removed in the form of carbon dioxide. It means that's known as decarboxylation. So this decarboxylation can be supported by pyridoxal phosphate or PLP. In short, this transformation, one of the bonds of the amino acid substrate is broken in the first step of the reaction, and the decarboxylation breaks the bond joining the carboxyl group to the alpha carbon. Transamination, racemization, the alpha beta elimination breaks the bond joining the hydrogen to alpha carbon, and the alpha beta bond cleavage breaks the joining of R group to the alpha bonds. Therefore, generally we have to see these all scenarios under these introductory parts of chemistry of natural product. So every student or every stakeholders can be understand from this video or from this tutorial video that natural product is anything that can be made from living organism. This living organism may be a plant, marine species, algae, fungi, or a bacteria by itself. And this natural product can be classified as primary and secondary metabolite. And the primary metabolite means the one that directly involved in growth and survival, but secondary metabolite cannot be directly involved in growth and survival, but they are very important for defense mechanism. Therefore, the equivalent term for secondary metabolite is simply natural product. That means. So this natural product is very important in different industry, in medicine industry, in spice industry, in food industry, in perfume industry as well can be used. So this secondary metabolite and the primary metabolite is mainly different based on their theoretical definition rather than the chemical precursor as well as their chemical structure. So by using chemical structure or chemical precursor, one cannot identify primary and the secondary metabolite rather than to use what the theoretical definition from this point. So thank you for watching. If you have any comment, any suggestion, any question, you have to write under the comment section of our channels, and you have to be patient for having questions for these courses, and you have to understand the concept behind and share for friends as well to know more about the courses. And you have to scan your environment so as to gets very interesting things from this natural products. So thank you for watching in general.